Hello everyone, I'm Jiaju from the technical department of Dharma. This video will tell you all about how to use Truwave for laser mapping. Here are all the materials we need. One is our laser software Truwave, one is the test graph we need later, and one is the video player software Arena. Other software is also acceptable. But it should be noted that this playback software needs to be capable of outputting NDI signals. Then there is another one, which is laser material. Two videos are needed for laser mapping. One is played on the main screen containing all elements, such as the background, and a complete video. Then there is another one that just needs to be identified by the laser video of a point or a line. Now, let's open our laser software first. For the laser, we chose to connect the IP of the laser network cabler, which can be set by ourselves. There are two green serial numbers here, indicating that our control BX has been normally online. Then we click on Preview and this to create automatically. If it's the first time, you need to click on this Auto Create. If we save the file later, there is no need to click on this again. Instead, it's directly in the File option here in the upper left corner. Just open our saved file. Then we choose to enable the laser. Randomly select several materials and OK. We can see that the laser can emit like normally. Now let's open Video Player software. Find the advance here in this output. OK, we need to set several screens. First of all, this screen is for projection or a main screen. For the output device, choose our projection equipment. In the input area of the slice here, we select the whole area, and in the output area, we also select the whole area. Then we can click on this plus sign to add a new screen. I have already added it here because we have two desk lamps. So let's create two new screens. One is for the laser on the left, then name it. Then, here in the input source, I want to select for NDI, and the other desk lamp is also chosen as NDI. At this width and height, here it is uniformly adjusted to 640 by 360. Near in the output area of the slice because this is the laser on the left, so we need to choose the left half area here. This is the lamp on the right, so the right half area should be selected here. Note that what I have changed here is the input area. The output area, we need to select the whole area. And another desk lamp is also the whole area. Then we save. Now we need to test this graph and put it into our video playback software. We can see that there are 3 layers here. In the advanced stage, we need to set a fixed layer for the main screener. I have set layer 3. Then the laser video is placed on the same layer. Here I've uniformly placed it on layer 2. Put the test graphics into the layer of our screen then. Let's play it. You can see that. Normally our test graph is an 88 grid, but now the output is an incomplete graphic. So then we adjust its size here. We click Stretch and look. Now the whole area is presented in 88 grid, which is correct. We have 2 lasers now, and 1 laser lamp should correspond respectively to an 88 grid. We can drag the slice on the left into it, then stretch it again. Now the area on our left is just an 88 jarida, and we need to use the laser on the left to align with this 88 grid. Let's double-click this green show, then click on the details. We'll click on the test graph here for calibration. Then a test graph of the grid can be output. Then I select this pointer, for example. I select these 2 points above. I want it to move downward, just move this axis. Okay, I want to move to about the same height as the screen. I'll choose the 2 dots on the left again. Line it with the screen. At this time, a situation might arise. When I move the one below or any 2 of these points, the direction of the point is reversed. Let me demonstrate it to everyone. For example, now my whole graphic is moving downward, but we can see now the whole figure is moving upwards. It's the opposite. This indicates that our Y is the opposite, and we can make adjustments here. Move the slide shaft below the same. If we find that the z-axis is reversed, it can also be adjusted here. Then, after making the adjustments, we just need to click on the application. The yellow dots indicate that I have selected these two dots, and the grey dots indicate that I haven't selected these two dots. Now, I select these 2 points on the rig to, I continue to align our test graphics. What we need to do now are these 4 points align the 4 corners of the graph we test. After we have completed the adjustment of the 4 corners, we UP-graded the grid to a 22 GRI DTO, adjust it in more detail. Even though the graphic display here in my software is a B-normal, it's still okay. But only the test graphic points output by my laser with our video player software. It's fine as long as the points of the test graphics play correspond. Now let's continue to advance. We need to keep adjusting the details, adjust to an 88 grid. We can see that when we upgrade to the 80 GRI, the grid output by the laser will flicker very obviously, which is, normal because of the 88 grid. The number of points contained therein is very large. The more detailed accurate our laser grid adjustment is, the laser mapping will be more precise. After we have made the adjustments, click on the application, then determine. At this point, we need to delete the slice on the left of the current layer. Give him a slice on the right, and stretch it as well. Stretch it into a complete 88 grid. Then we go back to the laser software to adjust the lamp on the right. Let's click on this test graph. After adjusting both lasers, we need to switch it to NDI stream here. Click on this NDI. Here at this NDI source, select the name of the slice we just set. It's the laser on the right. For this, we should choose the GPU of our computer itself and the detection method. Here we choose this smart stroke, and the box on the right shows black. It indicates that the connection is normal. Then we click OK and set the light on the left as well. Let's go back to our video player software. Delete this slice as well. Next, we need to put our laser materials into our video player software. The main video will be placed in our layer 3U and place the laser point video on layer 2 of our laser layer. After putting it in, we also need to adjust and stretch it. How we play the video. 2 videos play simultaneously. Then we can now see the point of the laser follow the video to perform laser mapping.